Welcome all. I am just waiting for everyone to join, so hold on a second. Okay. Okay, let's begin. So hopefully you can hear me. Can someone say something? Apratim, can you hear me okay?
Hello.
Yeah.
Hello. Yeah, we can hear.
Yeah,
Okay,
I can hear
perfect.
you.
Perfect. I recognize some of you. Great. Very excited to have you all in this class. This will be an interesting new experience for all of us. Fortunately, I have actually, believe it or not, I have actually taught this class on Zoom several times before because of my schedule. So I have a little bit of experience doing this, which should hopefully help. Okay, so we are on Zoom. This, I'm going to start. First of all, everything will be recorded, as you can see, and it will be posted on Canvas. So, which will hopefully make it more convenient for you. That's my goal. And I will say a few words about myself soon. I just want to make sure everyone's in. Okay. So let me first share my screen. Okay. Hopefully you can see that.
Yeah.
Great. Let's go full screen. Okay, perfect. So my name is Rajesh Menon. I am a professor in the electrical and computer engineering department at the here at the university. And of course, you're all here because of this class, Optics for Energy. It is, of course, an ECE 5000 level class, also 6000 level. But it's cross-listed also with material science and engineering, also 5000, 6000, as well as mechanical engineering. So I know a few of you are from there as well. So welcome. This class, I should first preface by saying that this class is a little bit different than traditional classes that you might have taken. So I just want to be very clear upfront. So what the expectations are and what you need to do. The most important difference is that I want to give roughly almost equal importance to not only the technical aspect of this class, which is, of course, it's an engineering class, but also what I refer to as entrepreneurial parts of this class. And you will see what I mean by that as we keep talking today. So, so just be aware of that. So it's a little bit different in the sense that, of course, we will try to solve some technical problems, but my hope is that you will utilize this knowledge to actually apply to solve some real world problems. And I will emphasize this quite a bit as we go along. Let me say a few words about my background. Before coming to Utah, I was in Boston at MIT for many years. I was an instructor there, a student there for a long time, more than a decade. So, and my area of research is actually in this field of optics and primarily related to nano technology as applied to optics. Of course, nowadays we are utilizing these skills in my lab to try to advance technologies related to energy as well. So the subject matter of this class is very dear to me and my research. I also have a little bit of entrepreneurial experience. I've started several companies, so and made lots of mistakes. So one of my hopes is to convey what I have learned over the years, particularly from the mistakes, which is really where you learn quite a bit, and hopefully you can learn from that and have that experience. One of the goals that I'm hoping to get at the end of the semester is for you all to have an experience, albeit it'll be virtual, but an experience of working in remote small teams to produce something valuable. And we will try to experience this as if we were a startup. So that's the sort of experience I'd like you to get at the end of this class, in addition to the technical part of it. So from that perspective, this class might be a little bit different. But okay, so that was a pretty bit of a long preamble. What I want to do today is to go over the overview of the class, what I expect, the grading, and a few other details of the schedule. So as you probably saw on Canvas, the schedule for this class is pretty much set. I mean, if there are some emergencies, we will change things. For instance, a couple of years ago when there was a shooting on campus, I had to change my class, obviously, because classes were canceled. So things can change, but I would say 95% this schedule will be fixed. So my hope is that you can plan ahead, far ahead, particularly for your assignments, exams, and things like that, which we'll talk about. So this was my hope. Now, if there are any issues, of course, reach out to me. So I know, so I have kids and they are doing virtual school as well. So I know completely what the challenges are as a parent. And I know, you might have to balance lots of different things, jobs, family, and so on. So if you have any concerns, just reach out to me, okay? Just email me. We are here for you, and completely understand with COVID, there's lots of differences, things that are different and so on, and a lot of, so in a sense, I want to be very flexible, but at the same time, we want to make sure you get enough out of this class. Another important thing I want to say that I expect all of you to be either seniors or early graduate students, which means that you need to really drive this yourself. I am, in a sense, as a guide. I will give you problems and I will give you direction. And of course, I can also help you. But my hope is that you will drive where you go with this class or during this class by yourself. This is very critical. You will get what you will get out of this class, what you put into it. And in a sense, it's not an easy class because you do have to do quite a bit of background work. But hopefully the background work you do will be valuable in the sense that you gain the not just expertise, but also the experience. Okay, so let's jump into this. So also all these slides that I'm going to show you will be are already posted as a PDF file on the website. So you can also download them. I'll show you all this in a few minutes. Okay, let's make sure everyone's admitted. Okay, looks like it is. And of course, if you have any questions, you can post them on chat. The TA for the class, Apratim Majumdar, is also on Zoom. I will try to monitor the chat, but sometimes it's a little hard to do. Oh, I should.
Yeah. I'll be here.
Yeah, Apratim is right there. And Apratim, just a brief introduction, is a scientist, is a postdoctoral scientist who works in my lab. So he's very experienced. And he'll be giving some of the lectures during the semester, as you will see as well. And we are both here to help you, really to guide you. So take advantage of this, obviously. So everyone hopefully knows how to use Zoom. If you don't, please go to TLT. They have really wonderful website and resources, and they can walk you through how to use it properly. In our class, we will try to take advantage of the good aspects of Zoom. So first of all, I will leave my video on all the time, but you are not required to, whatever you feel comfortable with, and also based on your Wi-Fi connection. So my Wi-Fi at home is not great, so I completely understand, especially if my kids are on class as well. So, but I will try to leave mine on all the time. So you are completely free to do what you want. I have no expectation. However, I expect you to participate in class, as we will talk about, because this is really an interactive class. And the way we will do this is either through breakout rooms, where we'll kind of split up into smaller groups and kind of discuss problems and innovations and brainstorming and so on, but also through polling and a few other things as well. And we'll come to Slack later on, which is actually a wonderful tool as well. Okay, so let me oh yeah, and also on Zoom you can use annotation. So for instance, I'm going to annotate something. So of course everyone knows, this is an annotation in Zoom, right? And you can do this as well. So if you want to point to something, let's say, oh, I have a typo here, you can point it out yourself. So don't be shy if you want to do that. I'm giving you permission now. Of course, you can also just talk. Okay, but sometimes when you have a lot of people, it's hard to talk. Okay, I think that's it for Zoom, and everything is recorded. So, okay, let's keep going. Okay, so this is an interactive virtual class, which means that we won't meet in person, which is fine. We'll try to make the best of it. We will meet on Tuesdays and Thursdays at 12:25 to roughly 1:45. The time might change a little bit depending on what we are doing. Of course, invitations were sent from Canvas, and all of you are here because you got it, so that's great. Now, I would like to do Zoom office hours as well, and I'm relatively flexible because my travel schedule is basically shut down. Although I still have a little bit of travel, which is which is a little difficult. But right now I'm thinking about something like evenings, because for those of you who might be working or it might be hard to get a hold, get time off. This is what I thought, but 6 to 7 on Wednesdays, but maybe it's dinner time for you, so you don't like it. So, so feel free to suggest something else. But I have a brief poll here just on preference. And this will just be an open office hours, which basically means that you can come on Zoom or potentially on Slack and just ask questions or concerns or questions or any other things you want to discuss. Let me see if I can launch this poll just as this is a good test, because it's a simple poll. Let's see. Sorry, I haven't done this before. I didn't get a chance to test this. Okay, polling. Okay, I'm going to launch the poll. The poll just gives you 5 options. You can pick one. Of course, this is just a practice, so don't feel confined to this, but at least it gives me an idea. And if you want to change the time, you can just message me later on. Okay, here's the poll. So I'll give you about 30 seconds to, hopefully you can see it, to fill out the poll. Yeah, you don't need to pick Wednesdays. It's just something I almost arbitrarily picked, but so I'm relatively flexible. And if 6 to 7 is not it's not great for you, then don't worry. You can just send me an email. Since we'll all be on Slack also, it's very easy to ask questions at any time, any day. So this is really just a little bit of a formality. Okay, a couple more people and then we're done. Grab some water, hold on. Okay, one more person. Maybe that's just me. Okay, let's end the poll. Share the results. Looks like Wednesdays wins, but pretty split. Okay, so again, as I said, we'll start off with Wednesday. So tomorrow, I'll leave my Zoom open. So if you have questions, concerns, feel free to join. You don't have to join. Nothing is mandatory here. Okay.
Sorry. So like I have a lab until 6:05 on Wednesday. So I don't think, so I think, I'm just wondering, is that a Zoom meeting? If that's a Zoom meeting, I guess I'll miss maybe the first 10 minutes.
Oh, yeah. Yeah. So it's, I don't know who asked the question, but by the way, I'll try my best to remember names and faces. I'm terrible at it. So I apologize in advance if I.
Okay. So this is what I look like.
Yeah, no, it's fine. I'm just warning you. Don't feel bad if I don't remember someone's name. I'm just terrible at it. So to answer your question, this is what we refer to as open office hours, which means that there's nothing. We don't have an agenda, so I'm not going to present something. So, but if you have a question or you have a concern, or let's say you're concerned about your grade or whatever, you can come in and ask. Of course, this is just a formality. Like I said, I'm available all the time. So just email me or, excuse me, just send a message on Slack. So you don't need to join the office hours, but it's just an additional resource in case you would like to do it. So
Oh,
sometimes
that's
we
right.
may
That's
not.
right. Yeah. Sorry. Yeah. Thanks.
No problem. Yeah. No need to apologize. Ask any question you have. That's what today is for. So, okay. The next topic is Slack. So Slack, as some of you know, because I noticed some of you already joined, is a discussion. It's a chat feature, basically a chat app. Slack is a pretty. By the way, it's a startup which was started about 6-7 years ago. I've been using it for about 5 years. Most of my labs on Slack because I'm travel so much. It's really hard to do things in person. So it's I would say 90% of the most innovative companies in the world work on Slack or their competitors. There are a few other competitors. Slack is nice because it's free for most situations. So what is Slack? Slack is, I'm going to show you. This is what it looks like. So you can see. It's essentially an app. You can put it on your phone, on your laptop, whatever, iPad, whatever. And it just lets you type stuff. Okay, I can type gibberish here. Okay, so I can ask, okay, what is my grade? You know.
Is this for this class?
Yes. So this is a channel for optics for energy. I have many other channels.
Maybe add me.
Oh yes, I think I sent you an invitation, Apratim, so you're on it. So you can just, type. And of course, this is completely asynchronous as opposed to what we are doing today, which is synchronized, which means that you can ask whatever you want at midnight or whenever. I may not respond to you at midnight, but when I get to it, I will respond to you. Also, of course, you can chat with your other students in the class as well. So later on, when we form remote teams, you will have to work with your team members. You'll have to talk to the people. And maybe you don't want to talk in person, using voice, you can just chat. Of course, Slack also has an option for voice as well. Let's see, there was a message. Okay, Alex said he didn't get an invite. Okay, Alex, I'll try to, we'll try to resolve this after the class. Let's see. So also Slack allows you to send files and things like that. So it's a really nice way to keep things organized, and you have a really nice repository of everything you're doing. Of course, I also suggest that, okay, Alex, yeah, actually I see your name there too, so you're added. Great, perfect. So you're already on. Let's come back to my, so that's Slack. If you have trouble, just send me a message or send me an email. That was the quick demo. Is there anything else? Let me think. So you can create one thing which will be nice to point out is you can I can create channels in Slack. So let's say your team is called I don't know, Sun Ninjas, whatever, so I can create a team basically and then add whoever I want into that team, and then that will be your channel, which means that people who are not in your team cannot see what's in there, but within your team can see there. So it can be a little more private if you needed it to be. Anyway, so you can do interesting things like that, and I believe you can do this yourself as well. I don't need to be actually doing this directly, but anyway, so that's one. Now, the next question is about textbooks. We won't have a formal textbook for the class. Everything that you need for the class will be provided as a PDF, videos, media, whatever, okay? And everything will be posted on Canvas and onto my website, which you can see here, lons.utah.edu, and we'll go there shortly. Okay, let's see. Oh, you said you're not either, but yeah, let's come back to that. Okay, so what are we hoping to get out of this class? So before I talk about this, I mentioned before in the beginning that what I want you to get out of this class is some basic understanding of optics, but also an experience where you applied this basic understanding to try to solve some real world problem related to energy. These are my two big goals for you at the end of the semester. And hopefully you'll you'll achieve those goals at least significantly, let's say. So what's optics? Optics is basically the science and engineering in flight. We will, being an college of engineering, we'll focus primarily on the engineering, but there are a few things that you need to know, fundamentals. But specifically, this class will be applied to the efficient generation and utilization of energy. Now, this is a very broad definition, and as you will see through the schedule, we'll talk about lots of different things. And I'm very, my goal is not to constrain this definition, but really to expand it. And what I mean by that is that, let's say you come from the world of mining, okay, which has not necessarily anything to do with clean energy, but related to, let's say, dirty energy. But you want to make it more energy efficient using something we talk about in this class. Let's say you want to build a new type of camera which allows you to do something more efficiently, so it improves the efficiency of mining. That is perfectly fine with me. And if you're really passionate about it and you can convince a couple of other of your colleagues to be passionate about it, I am more than happy for you to form a team and tackle that problem. In fact, I would prefer something like that as opposed to me just dictating what you do. Okay, so that's just a simple example. Okay. What are our objectives? We want to learn some fundamentals of optical design and engineering. And this is, of course, very important because the goal here is not to become experts at optics or optical design, but know enough of optics that you can actually question engineers that you will hire when you are the CEO of a startup company. So let me repeat that, okay? I want you to understand the fundamentals of optical design and engineering, not only because I want you to be an expert in this, which is fine, which is great, and that's what I am, that's my area of research, but I want you to be able to understand the engineers you will hire when you are the CEO of a company. Okay, this is a very important distinction. I want you to really think about this. Now, what does that mean, what I just said? What that means is I want you to get not just understand equations, algebra or calculus or something, which is important, of course, as engineers, it's very important, but to really get an intuition of what does that integral really mean, okay? And I will really, really try to emphasize this. That meaning of the gaining of the intuition is a super critical part, in my mind, of learning in any highly technical field, actually any field for that matter. Okay. Whoops. Okay, great. I'm glad everyone's chat. So feel free to chat with each other too. Yeah, it's no problem. Yeah. Sorry, I may not monitor it because I have to talk. So, okay. The second aspect, so I think that's somewhat clear to you. The second aspect is I want you to apply what we learn, which you will see, we will learn all the fundamentals probably by the end of October. So the first third of the class, we will learn the vast majority of the fundamentals. I want you to take that knowledge and then apply it to some innovation. Now, what does that mean? That means I want you to identify a problem that you want to solve. Okay, I said want to solve, not you want to solve, not I want you to solve. So of course, I can dictate the problem I want you to solve, but more importantly, I would like you to be passionate about the problem you want to solve. So that's an important distinction. So I want you to identify the problem and try to think about what we have learned and apply to solve that problem. Okay? And you might think this is crazy. There's no way I can solve a problem, like global warming or solar energy or whatever, because I don't have enough background. It's actually not true. And I'll show you many examples of this, okay? There are lots and lots of people who come from outside who are not subject matter experts, but they learn enough of the subject matter, but because they see it from a completely different perspective, this is why diversity of perspective is very important, that they can see the solution to a problem which no one else who's in the field could see. And I've seen this happen again and again, many, many, many times. So that's what I mean by that. Now, what does innovation also mean? Innovation also means that you need to create new solutions or new ideas, solutions to a problem, but they have to be practical. They have to be hopefully high impact. Practical, what does that mean? Practical means it doesn't violate the laws of physics. You can actually do this in without $1 billion. It's not like, oh, if you say, oh, I want to mine resources on asteroids. Yeah, that's a great idea. You can do that. There are companies trying to do that, but you will need a few $1 billion. It's not really practical. I mean, maybe it is practical. So let me not bring down the vision. But anyway, you have that. You get the picture. Now, high impact. For me personally, high impact means you can impact the lives of as many humans as possible. This is what I would define it, but it can be anything you want. It can be you want to build the next Google and make a ton of money, which is fantastic. Just make sure you donate some of those proceeds to the university. The way I think about this, it will be, what can you do to bring the highest, what can you do to improve the quality of life for the largest amount of people? That would be one way to think about it, but you can define it many different ways. Finally, it has to be commercializable. What does that mean? I don't want you to build a nonprofit, although there is certainly a great place for nonprofits. I have nothing against them. I have great friends who work for Oxfam, for instance, all their whole career. So I have nothing against them, but for the purposes of this class, I want to make this a for-profit idea. So what does that mean? That means you need to not only technically innovate, but you need to figure out how to make money from it. And this will be the second half of the class. And to me, this is the part of the class which is most uncomfortable for us because we are engineers. We are not taught to think this way. But I want you to be uncomfortable. I want you to think this way because this is one of those skills which I never had a chance to learn when I was a student. And I'm hoping that you get the experience or at least have a chance to think along those lines. And you will see that it is very, very critical that as a leader of a new entity, new company, or a new team at any company you work for, that you are able to not only contribute technically, but also contribute from the commercialization side of things. And these are really, really closely interlinked as well. And the final goal that I have is really be aware of emerging technologies in the horizon. There's lots of really, really great, fantastic stuff happening in this field. And I'll try to point to many of these, especially on the website. And I want you to be aware of them. We'll talk about some of these in some of the lectures in the second half of the semester as well. Okay. By the way, if there are any questions, just feel free to say something, but I will check the chat occasionally, make sure I don't miss anything. Okay. Or Apratim will check the chat. Okay. Now, what are the specific topics that we're going to try?
Yeah, I'm checking it. I'll let you.
Great, thanks, Apratim. So the main topics, what are we interested in? Okay, optical design. And the two types of optical design, one is imaging optics, which is what we think of usually as optics. What does that mean? If I take my phone camera, which you can see here, and the camera that we are seeing, this is optics design, right? And the billions of these being sold, right? Literally, this is probably the most of any product that's made, but it's pretty complicated, right? So we'll think a little bit about that, how to do that sort of stuff. You can, of course, the same applies to microscopes, telescopes, all kinds of things like that. Now, there's something called non-imaging optics. Non-imaging optics, as the name implies, means that you're not forming an image, but there are very different principles that are applied. And examples of that would be your automobile headlights, your lighting fixture in your kitchen, right? Or the LCD backlight through which you're seeing this presentation, for example. So all kinds of things. And of course, this is relevant to us because a lot of the solar concentrators and and daylighting systems, all this kind of stuff falls under the rubric of non-imaging optics. The second topic of interest is, we can think of this as thermodynamics of solar thermal and photovoltaic devices. Now, thermodynamics is a very important topic. It essentially pervades all the technical fields, I would say, whether you're working in particle physics or whether you're working in cell biology. I would say thermodynamics pervades both all these fields. So we will talk a little bit about that. Of course, we will only touch the basic surface of it, just enough so we can understand how it affects optics. So just be aware of that. So it's not a thermodynamics class, but just enough so we can understand things. We'll also talk about novel approaches to light management in photovoltaic devices. This is, of course, a very hot area of in the industry today, so we'll dwell on that. Emerging areas of other related technologies, things like liquid crystal displays, OLED displays, because again, of course, if you think about your phone, which takes, to charge the phone, the reason you have to charge this phone is because the display takes a huge amount of energy. So an example of something we'll also think about, but all kinds of other things as well, recycling resources and so on. And we'll see more of this as we look at the schedule. Finally, of course, entrepreneurship. Last but not least, again, like I said, this is equally important in my mind, at least for the purposes of this class. Okay. Grading, of course, yeah, this is the most important thing for all of us, all of you, not for me, by the way. So I should make a caveat to my goal here is not to give you a hard time. Let me put it that way. So my goal here is for you to learn, okay? So, and I say this every year, but students are always kind of a little bit surprised. The grading is important from the perspective of for yourself to understand whether you're learning. And for me to understand if you're understanding what I'm talking about or not, right? So it's important from that perspective. But my goal here is not to give you a bad grade. This is not my goal. My goal at the end of the semester is to have you earn a good grade, but most importantly, gain intuition and knowledge and some experience from this class. Okay, so be very, very aware of this. And you need to put in your effort, not for your grades, but because you get something out of it. Not the grade, I don't really particularly care. Okay, so having said that, our specific plan for grading is there's a midterm on October 15th, which will be about 20% of the grade. Then the rest of it's team-based projects. So 80% will be a total of 6 team-based assignments. The first one is due September 8th, and we'll talk in some detail about this soon. Just be aware that the 5300 series or section 90 students are graded on the team-based projects alone, so this part alone. Okay, of course, you're more than welcome to take the midterm for extra credit. I'm not gonna prevent you from doing that. And we'll talk about all this in a little more detail next. But first, let's go through the schedule. So first of all, to get the schedule will be on Canvas, but it's already on this website. So I'm going to walk you through the schedule. And the reason to walk you through the schedule is I want you to see my logic of why the schedule is there. And that way you can prepare yourself on how much time you need to spend on things, okay? So just a quick note here. Let's go to the schedule. Okay, so courses, that's an IBC class. So first thing you will see is that, zoom out a little bit. Okay, so all the announcements will be here. So for instance, I posted this article. So usually there's always something really exciting happening in this field. So it's very easy to see interesting things. It's all mandatory, but I encourage you to read them. So for instance, there was a very recent news article that I'll go to in a second, which talks about 5 grand challenges in thermal energy to decarbonize Earth. So you can click on it. It should take you to a link. In this particular case, it's this article by Henry Assegun, who's a mechanical engineer at MIT, who's laid out this really nice framework for thinking about the grand challenges for decarbonizing the Earth's energy system. So it's kind of a very general article, and if you actually read the technical paper, it's much more related to thermodynamics. But I would encourage you to take a look, and you might not understand most of it, which is fine. But at least you'll get something out of it. Okay, we talked about most of the stuff. So we talked about Slack, Zoom, Adobe Spark. Okay, this is something very, very useful, and I recently found out about it. So we all, as University Utah affiliated people, have access to this for free. So you click on this. There are instructions. Go to sparkadobe.com. It allows you to link in. And what does it do? It allows you to make beautiful websites and Instagram posts if you want, and Facebook posts and all that kind of good stuff, right? So anyway, it's completely free. You can sign in with your UID. I encourage you to play around with them. Okay, Code 5 and Light Tools. So for the only reason I'm pointing this out is because you might want to use it for your presentations. So you will see a lot of you don't have to, by the way, these are all suggestions. I'm not mandating anything specific. I'm just giving you resources, okay? Code 5 and Light Tools, so let's click on this. These are optical design software donated by Synopsys. Synopsys is a very large company which makes CAD software for all kinds of industries, including optical design. Code 5 and Light Tools are very expensive, many thousands of dollars per year software that is used by practicing engineers in the industry today. Synopsys has kindly donated licenses for us to use in this class and also at the U. So as long as you're a student at the U, you have complete access to it, which is really fantastic. So, so you can click on it and it gives you lots of overview. And this is installed in the CADE lab. So you should be able to remotely run it. So you don't need to go in anywhere, okay? And we'll give you more details about this later on. So you can read about it. So for example, this, let's see, what can I say? So, yeah, so this, for instance, would be an example of a lens camera design for a cell phone, for example. I don't know what it is, but something like that. So you can see all these different lenses and how to simulate them and things like that. So this is very useful. Light Tools is a related sister tool where you can simulate things like the backlight of a cell phone, for instance. So the physics is the same, but the application, the equations, how they simulate it is a little bit different. But so let's see, what is this? So this does polarization. So, you know, for instance, if you have a projector, like for instance, Moxtech, as some of you know, it's a company based out of Orem. Again, very large, owned by a large Japanese consortium. They make these polarizers. So light comes in here, as a light bounces off and so on. So these are rays of light. For maybe for projectors or whatever. So it's also relevant to local industry as well, for instance. That's the only reason I mentioned Moxtech. Anyway, you have access to it. And we will have a couple of lectures on this. In fact, we will have a guest lecture from Synopsys itself. And so you'll have lots and lots of opportunities to practice and ask questions and things like that. And yeah. Okay, what else should I point out? Okay, so we will also have some guest lectures, which is really exciting. One from VentureWell. VentureWell is actually it's an organization which is an entrepreneurship organization, which is nationwide. It gives you access to a network of entrepreneurs, so you can read through all this stuff. So they are science and engineering entrepreneurs. Then you can network with them. They also do fundraising, give you feedback on your you know, innovations and things like that as well. We will have one of the directors of VentureWell as well. And very excitingly, I have fortunately been able to line up guest lectures from industry. And most of these are my friends and former colleagues, so it's great. We have someone from Intel who's working on perceptual computing related to virtual reality, augmented reality displays, things like that. A very good friend from Google X. Now, for those of you who may not know, Google X is the super secret labs of Google, where they don't even publish the address of the building. So in fact, I gave a talk there once several years ago, and it was a little weird trying to get there. It was trying to go into the CIA or something. But anyway, interestingly, my friend, his name is Philip, he actually led a team which did what's called floating solar. So Of course, Google has an interesting problem because they run, which we don't think of, they maintain data servers around all over the world. And data servers use a huge amount of energy. In fact, I would say maybe 50, not quite 50%, but close to it of the cost of Google's business is energy cost. So anything, so this is, by the way, why a lot of data centers are located in Oregon and in Sweden and Finland and so on, because there is cheap hydroelectric power. So it's weird situation, weird question. So they have this incentive to reduce energy costs, and they had this project, floating solar, in order to do that. We'll hear about this. We'll also have someone from Apple talking about some optics there, and of course someone from Synopsys. So it should be a really, really exciting semester. So, okay, I won't go through this again, and then let me watch the time. Oh, I ran out of time, so let's go through fast. So all the details are here as well, so you can read it. Okay, so if you come here, I call this as a tentative schedule, but it's more or less the actual schedule, let's say. So today is the overview of the class. Now, and the lecture notes are right there. You see the PDF, you click on it, there's a PDF, okay? So you should be able to download everything you need. And I will post them before the lecture. So it might be the few hours before, might be a day or so before. And there's additional resources typically. So in this case, Solar Coker Basics, you click on it and all that good stuff. And if you click on this, it'll bring you to some videos where we'll post the different videos for the class. And these are all on YouTube as well, but basic stuff this year. Of course, all of this will be posted on Canvas as well. Okay, so Thursday we'll talk about project topics. As I said before, 80% of the grades depend on projects, and this is a very, very important part of the class because I want you to get this experience. So I want to introduce some of my favorite topics, but that doesn't mean you have to pick them, but I want you to get a sense for what I expect you to do, okay? So we'll talk about that on Thursday. The next week, both lectures will talk about geometrical optics. This is imaging optics. How do you design cameras, lenses, use lenses to design optical systems? And Apratham will be talking about this. And by next Tuesday, I will assign the project teams and topics. In fact, we'll talk about it soon. I have to speed up a little bit. And the week after that, we'll talk a little bit about thermodynamics. And that's, by the way, your first assignment. We'll come back to that. So the assignments are shown in red, so at least you'll remember, okay? And then we'll talk about non-imaging optics. Assignment 2 is due September 15th. Then a little bit more on non-imaging optics and some measurement ideas. This is optical ray tracing, Synopsys lecture. Assignment 3, September 29th. Some other very interesting topics in statistical ray optics, again, relevant to solar energy. I won't talk about it much here. Oh, this is a very exciting lecture on optical design for recycling, where we think about how is optics applied in resource recycling. What do I mean by that? Recycling plastics, for instance. Huge problem, right? Think about what's happening. We can't keep throwing them in the ocean. It's just not possible. So what can we do about it? So that's a very, very important problem. Hopefully we'll talk about some solutions. A little bit on measurement of photovoltaics, so there's some practical stuff. And this is the midterm exam. So we'll have a review that Tuesday. But of course, all of this, everything we cover until October 13th will be included in the exam, and October 15th exam. The exam will, so that day we don't have class. The exam, I'm still trying to decide how to do the exam, but most likely it'll be just a timed exam, which means that you have 24 hours or something, and then you have to submit it. And we'll talk about submission and all that later on. Let's see, and after that, we'll talk a little, and that's the second half of the semester. So after that, we'll talk about solar cells, and then we'll start thinking about entrepreneurship. So there's an actual lecture on business model canvas, technology commercialization, some discussion. So we at University of Utah are fortunate to have a very, very astute TVC, which is a Technology Venture Commercialization Office. So Technology Venture Commercialization. And they have been fantastic to partner with us for this class. to come in for a Zoom panel discussion, and you will get access to some mentors as well. I'll talk more about that later. And then there's a VentureBell seminar. This November 3rd is your next assignment for a little more technical lectures. So skip through that quickly. Then we have our guest lecture from Apple. Assignment 5 is due then. Another guest lecture from Intel. And then we have Thanksgiving break. Finally, we have a guest lecture from Google. And then the last assignment. Now, these assignments, by the way, some of these assignments are actually in class. They're live Zoom presentations. So let's go back. Okay. So that was that. All of that will be posted on Canvas as well, but just my website actually has all of them already laid out. The Canvas is only for this week, for instance, or just today. Excuse me. So let's talk about projects. So first of all, the teams will be assigned by me by next Tuesday, September 1st. So what are the deliverables? So I'm very specific. I'll give very, very specific instructions. Some of these are already posted on the website. You can look at them, but they're from previous years. They will get updated, but it'll give you an idea. There'll be team presentations, which are assignments 2, 3, 4, and 6. We'll talk about those, what that means. Assignment 1 is just a short email or short Slack post. So very simple. Assignment 5 is a bit more involved. We'll talk about that next. Now, I just want to make a quick point about project topics. So I listed all these topics because this is of interest to me. I come from a developing country, and I'm very interested in these problems from that perspective. But that doesn't mean you have to solve these problems. You can pick whatever you want, as long as you can make a business case. You solve a problem for Google using this technology and become a billionaire, I'll be very, very happy for you. So you can perfectly do that. So, but I'm interested personally in things like solar cookers because they're simple. I like simple things: solar water pasteurization, desalination, refrigeration, daylighting, water heating, photovoltaics, optics, and recycling. This is very important. Others you propose. So to me, this is the most important thing, what you are passionate about, okay? But we cannot think only in technological terms. I don't want this to be just a purely an engineering design project. That's not what it is. I want you to think about cost, durability, storage, space requirements, whether you need to ship across the world, think about IKEA, right? Why is IKEA successful? Cultural factors, ease of use, climate conditions, and very, very importantly, the business model. How will you make money? Okay, assignments. This takes up 80% of your grade. If you are a section 0090 student, it'll make 100% of your grade. So let's talk a little bit more about it. Assignment 1 is due September 8th. It's a written report or just a brief email or a brief Slack post. You have to pick a team name. Pick something creative, okay, or funny or playful or whatever. And make a plan you can commit to for remote work. And what do I mean by that? I mean by that, commit to meet with your teammates once a week or twice a week or on a weekend or evening or early morning or this scheduling stuff. And if you have to change it, it's fine. I just want you all to kind of come to an agreement that you will do it and let me know. So I know that you actually had this discussion. Plan for remote work. How do you want to do it? And you don't have to divide jobs or anything, but just have a way where you are able to discuss at least once a week for 15 minutes, whatever it is, half an hour, whatever it is. Yeah. So come up with a plan. Assignment 2, so that's only worth 5%, sorry. Assignment 2 is a live presentation in class on Zoom. Just like I'm giving a talk, you will be giving a talk as a team. Okay, there will probably be 5 teams. So each team will get 10 minutes plus roughly 5 minutes for questions, 15 minutes per team. Okay, only the section 90 teams will not be presenting live. They will be submitting videos of their presentations. So the second assignment will be a literature review. Essentially, you would have picked a topic here, okay, September 1st, actually. So you'll do a literature review. What are the existing solutions? What's the state of the art? Pros, cons, comparisons, overview of existing technologies. I'll give many more instructions as we get closer. Assignment 3, it'll be a live presentation of your innovation. This is where you present your solution to a particular problem. Be bold, be creative, take risks. More crazy, the better, but of course you have to obey the laws of physics, obviously. 15%. Assignment 4, some technical details. So what does that mean? That means you do a simulation, you do some very careful analysis. You use Code 5, MATLAB, whatever. And if you are able to, build a demo, and I'll show you some examples of that. Of course, this semester, because we can't meet in person, doing a demo is much harder. But I'll show you some examples from previous years where some teams have actually built demos. It could be like a breadboard demo, which doesn't actually work, or it could be a demo that works, or you can just build it in your garage, take a video of it working and show it to us. So there are lots and lots of options. Okay, I'm completely flexible. Anything will be, anything to give credibility to your innovation. That's the goal there. Okay. Assignment 5 is a written report with final business canvas and video pitch. I'll talk about what that means shortly. Assignment 6, which is the last day, which is the business plan, presentation, commercialization plan. Okay. Assignments 5 and 6 are not presentations. They are something you have to submit. So assignment 5 is the business canvas. We will learn how to do this, so don't worry about it for now. And the second part of it is a very short video pitch. I said less than 3 minutes, ideally less than 1 minute, but you know, the shorter it is, the more creative and careful you have to think about it. This is essentially a video pitch for your innovation. Can be a product demo, elevator pitch, slide presentation, etc. I'll talk more about this as we get closer. Assignment 6 is a business plan with some basic sections. Again, we'll learn how to do this. Opportunity, go-to-market, strategy, market, and industry analysis. Technical product description, I put that in red because that's very important for us as engineers. Risks, economics, and team. Helpful resources will be provided along the way. Each team will be assigned a commercialization mentor. This is very important. I'll talk a little bit more about it shortly. You will be expected to Zoom meet with your mentor. This is outside the class schedule, not during the class. Again, take advantage of this opportunity. So mentors are folks who have volunteered their time to assist you, mentor you. They are local entrepreneurs who have actually done this before, and folks from the TVC who have seen it done before. So they can see your innovation and give you useful feedback, not just something I can give. I mean, I have some experience. I can also give you useful feedback, but I would say a little more experience than me, let's say. Okay, so that's the goal there. So really take advantage of their insights. So don't ignore this. And all I'm asking you is to meet for 1 hour each for 2 weeks. So the week of October 27th and November 10th. And I'll help you coordinate it, but you have to actually do the coordination of the exact time and date and so on.
I'm sorry, a quick question. So for the assignment, how many members are you expecting for like the assignment?
For the, how many students in a team? Is that the question?
Yes, in a team.
Yeah, typically 3 to 4. I would say 3.
Okay, great. Thank you.
And again, I forgot to mention this. If you have a preference for a teammate, just let me know. Just send me an email. I don't promise I'll put you together because sometimes it's good to expand your I would say your network, right? So it's kind of nice to have people with different perspectives. But if you have a very strong reason or something, or you don't even need to give me a reason, just say you like working with this person, sure, just let me know. I'll try my best.
Yeah, thank you so much.
Yeah. Same with the topics, right? Yeah, so if you're really excited to do something that's fantastic, just let me know. In fact, I prefer that, so. My goal is not to be a dictator. I want you to be excited about it. So I'm going to stop here for a second and see if there are any questions. I talked for a while. Let me get some water too. So. I want you to take a little Zoom break. Zoom's very tiring, as you probably know by now. So no questions? Let me see the chat. Okay, I answered those. Really, no questions at all. Don't be shy. You can talk.
I have a question
Sure.
about the, you're saying students that are 090 section don't need to do the midterm, but we're gonna, if we decided to do, it's gonna be extra credit. How it's gonna work? How is that extra credit?
Oh, by the way, hi Kaina. Thanks for
Hello.
emailing me before. Yeah, nice.
Oh
to
yeah,
meet
nice to meet you. Nice to meet you guys from the class.
What I mean is very simple. Let's say you did poorly in assignment 2, and you did the midterm, you can make it up. That's
Okay.
easy.
Okay.
Again, my reason for midterm is really not to penalize anyone, right? My goal is really for you to learn. And just keep in mind that although a lot of stuff that we talk about might be mathematics, right? There might be some matrix mathematics or a little bit of algebra or a little bit of integral calculus or so on. My goal is really not to squeeze you on calculus or algebra and so on. I'd like you to know this before, but my real goal is to make sure that you gain intuition from the algebra or the calculus. This is much more important to me. Yeah, go ahead.
I'm sorry interrupting. Just one more question. I think another person posed a question here. It's good for everyone. What will be the difference between the sections? I'm thinking one it's online, the other one's it's like
exactly.
I mean, it's all online, but like
yeah. So the section 90 students don't need to meet on the IVC schedule. It's what's considered asynchronous. So if you're a section 90 student, you don't need to come to the Zoom thing. You can just watch the recording. However, I mean, you are more than welcome to come to the Zoom thing. It's perfectly fine. I think the university simply, it's a formality from the university side. I personally don't care.
Thank you.
I treat you all the same. In fact, I treat you all the same whether you're an undergrad or a grad student. So be very aware of that. I expect all of you to be working pretty hard for this class. Not because I told you to work hard, but because you wanted to get something out of it. Okay, this is a very important distinction here.
Yeah, thank you very much.
Sure, sure. I'm very excited to see so many new people actually. Hopefully we'll have some really, so what I found is that people with very different perspectives, or people come from mechanical engineering or material science, or you work in some industry, they come with very interesting perspectives to all these problems. So when we start talking about innovation and so on, we see some really cool ideas. So it's a really fun class, actually, at the end of the day. I think hopefully you will experience what I experience all the time when I teach this class. So
there's a question on the chat.
Yeah, go ahead. Yeah.
I'm not sure if you already answered this. What is the difference between the sections, and how come one section doesn't have to take a midterm?
Yeah. So the section 90 is considered an online class, but all the other sections is what's called an IVC class. The online class has a different structure at the university, so it depends on what you registered for. And I believe the credits might be different. I'm not exactly sure, but the only difference right now is the midterm is essentially optional, so it's an extra credit. Otherwise, exactly the same. The presentations are video submissions as opposed to a live presentation. I guess that's a difference, but I'll be recording it anyway.
So there's another question. Wei asks, where can he get Code 5?
Yes, good question. We'll talk more about Code 5 later on, but you don't want to download it to your computer because it requires a lot of resources. So you want to run it on the university. Our license is a network license for the university computer. So what you do is you remote log in.
Yeah, I think CadeLab has it.
Yes, exactly. CadeLab. So for those of you who are at the who have been at the U before, you know what the CadeLab is, you know how to access it and so on. But for those of you who are new, we will give you a very, very clear instructions as we go along. So yeah, we'll have a complete lecture on code, 2 lectures actually on Code 5. So okay, so in the interest of time, let's. Are there any questions? That's basically it. Okay. Okay, so let's get started. So today I want to spend the rest of the time talking about solar cookers, but let's make let me say a few things about motivation. So I just wanted to say why develop technologies for the developing world? Now, this is an important question to answer because, you know, again, we don't want to develop technologies or companies or innovation just to create a nonprofit. We want to solve a problem that's sustainable. Now, there's a really nice correlation between solar resources with little access to infrastructure. So if you look at on the Earth's on our planet, where there's majority of solar resources, that's also coincides quite nicely with where there's little access to infrastructure. What I mean by that is electric grid, roads, etc. So that gives us a really nice opportunity to utilize those really huge amounts of solar resources for solving some problem. And in this particular case, an obvious thing is to create energy, right? So that would be a simple idea. Another important problem is that biomass resources are really fast depleting and also contribute to CO2 emissions. What do I mean by that? The vast majority of the people in the world, when they cook, they use what's called biomass, which is you know, old trees and twigs and things that are essentially on the ground, or, you know, organic matter that you burn. Right, so this is really fastly depleting, and of course it's terrible for CO2. It's bad for your lungs. There's lots of really bad things about it, right? So we want to, you know, that's, for example, that's would be, if you can have a very effective, cost-effective, as well as very effective solar cooker, then we can mitigate some of that problem. The third point is that there's a huge impact possible, right? 1 out of every 4 people on this planet have no access to electricity. So if you can touch every 4th person on this planet, that's an amazing opportunity. So, and then there are huge market opportunities to build sustainable technological solutions. Think about what Facebook is doing, right? Facebook has, and also Google, they have this project to deliver internet services around the world to all the 7 billion or so people, right? With balloons and so on. We'll talk a little bit about this stuff later on. So, I mean, why would they do it? Because if there's no market, and there's giant opportunities there as well. They're not doing this as a nonprofit. So we want to think along those lines. Tesla is another interesting example, although it's not so much for the developing world. Okay, so we'll talk about solar cooking the rest of the class today. I want to show a quick video on the types of cookers. So, and I'll link to this YouTube video later on, but let's just, so what I'm going to show is, whoops. I messed it up. Hold on. Gotta find it. There we go. So this is a company. It makes a solar cooker. It's called GoSun. I'm just going to play it first, and then we'll talk a little bit about it.
It seems inaudible.
It's very low right now.
Yeah.
You can't hear anything?
No.
Very low.
Let me see if I can turn it up.
This is the GoSun mighty little solar oven.
Is that better?
To prepare a meal.
Not so much.
Degrees and all
No?
without the use of fuel.
Yeah, now it was
Got better. Yeah, it got better.
Okay. I'll start from something
This
with
is
my
the
microphone.
GoSun stove.
Yeah.
Solar oven. It takes just 20 minutes to prepare a meal. Can roast up to 3 pounds at a time, reaching temperatures over 700 degrees and all without the use of fuel. It's fast, easy to use, and is safe to touch, even while blazing hot.
Hello, I'm Patrick of Applied Sunshine, and I've been working with the solar energy industry and trying to get it to power our lives for the past 12 years. I pulled a solar collector off of a rooftop at a home here, and I brought the solar collector down to my backyard, and I started tinkering with it. You know, I'm kind of a do-it-yourselfer. And before long, I'd gone up to the refrigerator, pulled out some hot dogs, and fired them inside the tube. And next thing you know, I've got lunch. Immediately, you know, I'm thinking, wow, this is some unbelievable potential. This technology has got real capability here to cook food and serve and eat.
In one simple, durable, and portable package, the Go Sun is ready for action for our fast-paced lives. The Go Sun stove can fry, bake, and boil wherever and whenever the sun is shining, summer or winter. The integrated stand allows it to be set horizontally when roasting foods, and with a simple adjustment, position vertically to sterilize water over your coffee. Smoke inhalation is the world's second leading cause of death, due to the more than 3 billion people still cooking with wood and charcoal. Beyond a human toll, it puts tremendous pressures on the environment and the finances and health of families. Women in rural India spend on average 50 hours a week gathering firewood, and Haitian families often spend as much as 50% of their income on charcoal. This has to stop. We aim to use the Go Sun stove to help break the cycle of poverty while reducing pressures on critical resources. Giving is at the core of our business model at Applied Sunshine. With every 5 purchases, we will equip and train a family to use a Go Sun for their daily needs. We're partnering with nonprofits around the globe to make this technology transfer a success. As we grow, our plan is to expand the program, empowering thousands more. Ordering a Go Sun stove will not only make for fun in the sun, but will help us share the power of solar cooking in the developing world. This is the Go Sun stove, a mighty little solar oven that takes just 20 minutes to prepare a meal.
Great. So go back. So it's just one example. I'm not endorsing a particular product, but just to give you an idea of what people have done before and what sort of things you have to think about when you do something like this. Now, by the way, the reason I picked solar cooker as a starting point is because it's very simple, and many of us have actually built one in 5th grade, or I think my daughter did this in 5th grade. So it looks something like this, right? So essentially, what is it? There are a few types of cookers. So this is a solar box cooker. It has a little box. There's an inner box here, and then you can put a cooking vessel in here. It's enclosed in clear glass or plastic, which lets the light in, visible light, infrared light, and we'll talk a little bit about that soon. Simple construction. You can use a reflector to increase the amount of light that comes in, which is essentially you're increasing the aperture area. Insulation is important because you want to make sure that the heat inside here is trapped. Okay, so it's a greenhouse effect. We'll talk about that. You want a slow, it provides potentially a slow, even cooking and safe and easy to use. Okay, so what are the sort of the other types of cookers? So you can have a panel cooker where it looks like this. It's made of, there's no inner box. It has reflective panels. It's the simplest because there's no box, no insulation, anything like that. It's least expensive because these things can be folded down, easy to transport. They are unstable in high winds, doesn't retain heat when cloudy. So the one advantage of this one is that it can potentially retain the heat because you have insulation here. This one doesn't. Of course, you can also have something called a parabolic cooker where you essentially shape a mirror to focus light. In this case, is a parabola. We'll talk a lot about this later on, which will focus sun's rays onto this focal point where you put the dish that you want to cook. Very high temperatures can be is possible. It can cook very quickly, so it's a little bit dangerous if you do this. It needs tracking of the sun. It's a very, very important point. In fact, this comes from the second law of thermodynamics, and we'll talk extensively about this. What does that mean? If the sun moves, you have to move this parabola. essentially. You have to tilt it. It's more complex and expensive. There's a risk of fire's eye injury. So, okay, now we're going to do something interesting. I want you to think about these three types of cookers. I'm going to split you into breakout rooms. I want you to brainstorm among your group, how would you improve these cookers? Okay, so I'm going to do this more and more in this class, so be prepared for it. You have to talk to your teammates, and I'm going to assign you randomly today, and probably next time as well. So the goal here is to brainstorm, think about, from your understanding so far and your experience, how would you improve these cookers? And I am going to give you roughly 1 minute or so, 2 minutes maybe, and I'm going to bring everybody back, and then I'm going to ask a few of you to explain what you suggested. Okay? All right, let's do the breakout rooms. And it can be very simple suggestions. Nothing's, it doesn't need to be anything fancy, but this is a practice, so we'll do more complicated things later on. Now, that is my breakout room thing. There we go. Sorry, hopefully these things will become more smoother as we do this more. Okay, let's see, there are 19 of you. Let's split them into, let's say, so maybe 6 rooms. So let's say 5 rooms. Okay. You should all be joining a breakout room shortly. Okay, hopefully, I think I accidentally muted everybody, so you can unmute yourself when you get a chance, and wait.
I think you only brought back us.
Same room,
Oh, okay.
okay. Oh yeah, we just have to wait. Sorry, I haven't played around with this too much.
So far,
Hopefully,
pretty smooth.
yeah, well, the Wi-Fi is usually the problem. I've been on a lot of Zoom meetings this summer, and typically my kids are on Netflix or something, then it's terrible. So I have to kick them out. Today I'm in my office, so it's better. Okay, we're still waiting for people. So while we're waiting, do you want to, does someone want to volunteer some cool idea, crazy idea, something interesting? Anyone?
I feel like for the third one, I've seen it on like TV before, and I think for eye injury and potential causing fire, all you need to do is just provide sunglasses and coverage, right? So when you're not using it, give a coverage of the stuff so it does not cause fire. And while using it, provide users with sunglasses. So like, I don't know, professional sunglasses so they don't burn their eyes. And I feel like for the system of tracking the sound, it does have like a little needle thing by the side of the bowl that like just tracks the sound within the design itself.
With the shadow of the sun, you mean? Like a sundial?
Yeah, like a needle, it has like a little shadow, and I think,
That's a really good idea. Yeah, of course, tracking is a very important problem. We'll come back to this many, many times, actually. So great. I'm really excited that you are thinking about this, because it's a very important problem. The safety is also very important. Of course, sunglasses are good. By the way, for those of us who actually work in optics, we don't wear watches or usually wedding rings and so on, because laser beams can hit off watches and go to your eye. So if you ever take an eye safety, laser safety training, they tell you not to do that. So most of us never wear it, but just something as an anecdote.
Oh, good to know that.
Any other interesting idea? I heard one from Linda, which was quite nice and important. So maybe Linda, do you want to share your idea?
Sure. I just said that when using the parabolic one, it seems like you could actually create a small battery pack that could be attached to the parabolic one that could also be powered, by solar, that would make it so that you could have the dish rotate with a motor rather than being something that had to be moved manually along with the sun.
Yeah, that's a really important point because let's think about it for a second. Let's say someone wants to bake a cake, and that might take an hour or whatever, right? Or something. Let's say something that takes a long time. You don't want to be sitting there trying to, turning it or coming back every 15 minutes or whatever. So having this automated is very important for many applications. So it's a really good insight. Also think about what a sunflower does, right? A sunflower follows the sun, right? So, and how does it do that? So think about that for a second. I'm not gonna talk about that because that's related to something slightly different, but we'll come to some examples later on, but something to think about. Any other interesting ideas before we move on? Anyone want to say?
I had an idea about the box cooker.
Yes, go ahead.
On the inside materials, you could use a wavelength specific coating that absorbs in the solar spectrum and then emits lowly in the whatever spectrum that it's, the thermal emission is occurring at.
Yeah, this is a really great idea, and we will talk actually about the specific thing later on. Now, let me give you another example where this is very important, is in agriculture. So if you have a greenhouse, let's imagine you want to have a greenhouse here in Utah that's all year round. You want to be able to design the greenhouse to let in the wavelengths of light that are useful for the plants, but not cook the plant, right? So that would be an example of what you want to do that is opposite of a solar cooker. So you have some wavelength selectivity here. This is very important, for instance, in the marijuana industry, which is a huge industry now in many states. So again, very, very interesting idea. Okay, so anything else? Oh, we are past time. So okay, go ahead now. I have time.
Professor, I have one thing to a suggestion. Something that we're thinking on our group. Like we have to make sure of the range of the temperature depending on our goal of cooking,
yes,
right?
Yes.
Are we frying? Are we boiling? What's the range of temperature we want for the cooker? So that's something we have to think about it for the cooker as well, correct?
Absolutely, yeah. This is very, very important because we don't have temperature control here. It's not an oven. So how can you do that very carefully? We'll actually talk about this in the next lecture. So really good. I'm glad you're thinking. The insight is very, very, very good.
I think one of the guys of the group brought it up, so.
Great, yeah. By the way, I just realized we are past time, and I'm not supposed to keep you past time, so I apologize. We have a few more slides. So I can stop here. I think formally I'm supposed to stop here, so I will stop. But if you have questions, or if there are any, I have time to answer questions, or if you have any other concerns or issues, let me know. I can wait a couple more minutes, but I think I'm supposed to stop right now. And we'll pick up from here on Thursday. I'm gonna stop the recording, but this will be recorded and posted on Canvas, and all the PDFs is there. But I'll stick around for a couple more minutes if you have any questions.
Thank you.
Thank you.
Thank you.